Hey guys, welcome back. So today we're working on this Generac GP7500e. And actually of that, I'm not completely sure because the model sticker is missing on this machine. But it does have electric start and fits the form factor of a 7500e. So it's either that or potentially a GP8000e. Either way though, this is a machine with problems. It comes to us from my buddy Jason. He said he picked it up about half a year ago, and unfortunately can't quite remember the backstory on this machine. But he believes he did get it running and that the engine went under load when no load was attached. So he shut it down, hasn't tried starting it since. So we're going to have to proceed carefully on this one because a generator that goes under load with no load attached is usually a sign of a bad stator. So let me get you set up a little bit better and get going on this. All right, so usually I start by checking out the engine. But given the symptoms Jason described, he was fairly confident this was the machine that sounded like it was going under load. So I think we should have a look on the generator side before trying to get the engine started. And this cover is a little bit rusted up here, so it's kind of holding things in place. All right, so nothing obvious. Let's get the AVR and brushes out of the way, and then we'll take a better look at the stator, see if there's any signs of a meltdown. Brushes were loose. And we got a zip tie right there we have to cut. So it's interesting that that brush bolt was loose. Brushes, though, seem to be fine. So potentially it was that way from the factory. I don't see any signs that anyone was in here. The zip ties are in place. And everything's covered in dust. Yeah, things look pretty good. The lacing's intact. Don't see any burn marks. Can't see all of it, but from what I can see, I don't see any signs of a meltdown. But let's take it a step further. Let's isolate the stator windings. We'll do some quick tests there. Just make sure everything checks out. So the other thing that comes to mind here too is that the engine that's on this machine, it is somewhat known for having camshafts that kind of round out the lobes, and that could definitely cause a run issue. That might be misinterpreted as the machine going under load. So if this checks out, then I think we need to just get this back together, get the engine running, and just hear for ourselves if there's a problem. All right, so let's check the main windings here. I'm going to use this milliohm meter. You can use a regular multimeter, but you do have to be careful because some multimeters have a lot of trouble reading values as low as we're going to measure here. So just be aware of that. Anyway, we're going to test leg 1 and leg 2, usually around 0.2 to 0.3 ohms. So this leg we're at 0.221. That seems good. Let's check it for a ground fault. No ground fault, so leg 1 appears to be good. Let's try the other leg. We should see about the same. And yeah, 0.215. So that appears to be good. Let's see if there's a ground fault. Yeah, no fault to ground. So it looks like leg 1 and leg 2 are good. We can also test the sense winding, which is the white and green wires. So one of the wires should connect to one of the legs and the other wire to the other leg. So let's check the leg we're connected to now to green. And we got 0.279, which seems good. Let's actually check that to the DPE. We should get nothing. So that appears good. Let's check the other leg, which should connect over to the white wire. And that appears good as well. Should not have a connection to DPE, which it doesn't. So yeah, things are looking pretty good. The only other thing we can check here on the stator are the blue wires. That is the DPE winding. That's the power supply to the AVR. And usually it's around 1.5 ohms, plus or minus about an ohm. And yeah, we're at 1.782. So the DPE seems to be good. And no fault to ground. So I would say the stator's in good health. Let's check the rotor. That is actually a very common point of failure on these machines. So I'll try to use the milliohm meter to get in there. It's actually pretty tight. And a bad rotor would not cause the engine to go under load. Yeah, the machine just won't make power. Huh. And it would appear that the rotor is bad. You know, I should get a value here between 40 and 70 ohms, although I am in the wrong range. So hopefully that was the problem. There we go. I saw 52 for a second. 58. Yeah, it's hard to get these probes in here, but the rotor appears to be good. So I'm actually going to get the brushes back on. We'll test the rotor through the brushes, through the slip rings. That should give us a more consistent reading. Although it might be a bit elevated, that will at least tell us if the brushes are good and should give us a little bit better read on the rotor. So we get the brushes reinstalled. And there's only one bolt holding this in. The other side is just a locating pin. So you want to be careful when you tighten these up. You know, you're just putting the bolt into aluminum. It's a fine thread, small bolt that strips out with very little effort. All right, that tightened up without issue. So now we can get the leads on here. Again, looking for between 40 and 70 ohms, might be a little higher since we're going through the brushes. And in this case, maybe a lot higher. Let's change the range. Yeah, that's pretty high, 355 ohms through the brushes. So yeah, let's actually clean the slip rings before we get this fully back together. So I'm going to pull the spark plug so there's no compression fighting us. We'll get a little bit of Scotch-Brite there on the slip rings and use a wrench just to rotate the engine to get them cleaned up. It occurs to me too, I haven't even pulled this engine over. So that'd probably be a good thing to check, but we'll get to it. Wow, that plug is probably never been out. And it looks like a torch plug, so we'll get that replaced with an NGK. And yeah, it's a Torch F7 TC. Plug looks all right. You know, it looks brown. Don't see any rust. So that is a good sign. So we'll cut up just a little piece of Scotch-Brite. Just enough to fit on really one of the slip rings, maybe a little bit onto the other. You don't want it too big because the rotor has some wires that are soldered, and you can see one right there. So you don't want to bump that with anything or you're going to break that wire. So I'm going to hold this on the slip rings, just rotate this with a wrench and get them cleaned up. Yeah, it cleaned up pretty well. Not perfect. There is still a bit of carbon and junk on there, but it's a million times better. So let's get the brushes back on there and see if the resistance is a little bit more in spec. All right, so we get the leads back on. And hopefully this time it's between 40 and 70 ohms. Yeah, there we go, 51.7. So that is perfectly in spec. Let's make sure there's no ground fault. Good, no ground fault. So the stator, the rotor, they're in good health. All right, so we'll get these wires reconnected. The neutral is from the stator and the neutral and the ground. So this is a bonded neutral setup. And if you're going to connect this to your house, this is the bond you would break. You would not want the ground connected to neutral. Instead, you'd relocate it just to the body of the stator. And I'll leave that loose for now until we get all the wires connected. Okay, and lastly, we need to connect the AVR. So I'm probably going to leave the end cover off though, and not secure the wires fully until we know that, we're 100% on the power side of things. So get the wires reconnected to the brushes. The red one goes to the left. If you get it backwards, it's not going to damage anything, but your generator may not power up. Because there are small permanent magnets on the rotor. And if you hook this up backwards, it's going to try to flip the magnetism, but the permanent magnets, they can't flip. All right, so let's check the oil real quick. Yeah, we're filled up right to the last thread, and the oil looks basically like new and does not smell contaminated with fuel. So the oil checks out. So let's test the battery real quick. Usually they're dead by the time I get to them. And surprisingly, we're at 11.99 volts, so this might have enough in it to crank. Let me hit the button. Beautiful. So there's no plug in it right now. Let's add a plug, see if the battery still has enough in it to crank the engine. So we're going to get a brand new NGK in there, BPR 6ES. And I'm noticing the carburetor too looks pretty new. The breather is also installed incorrectly, so yeah, I'm willing to bet someone swapped out the carb recently. Throttle plate's not stuck, and this needs to be flipped around like that. So we'll do that in a minute, but let's actually pull the drain bolt, see if there's anything in there. Yeah, just a tiny bit. Definitely old. Smells old, but the bolt, nice and clean, no varnish, no rust. So I'm going to give this carb the benefit of the doubt. You know, based on what I'm seeing, I think it was recently replaced and is actually pretty clean inside. And it looks like the fuel valve was left in the on position, but the filter completely empty and looks brand new. So yeah, someone was chasing a problem with this at some point and ended up selling the machine or potentially throwing it away. Cap looks good. That's usually a good indicator of the condition of the tank. And yeah, the tank, absolutely spotless. Well, so far, everything is checked out. So it's making me wonder why someone got rid of this machine. You know, the generator seems to be good. The tank is good. The battery's even good. And the carburetor appears to be brand new. So we might have an engine issue. But let's check the air filter, make sure it's good before trying to start it. Yeah, filter is also brand new, although we are missing the piece of metal that goes right there. But otherwise, airbox looks good. So I'm actually going to oil this filter up. It's dry. There should be oil on it. I'm going to look around too. I might have the missing piece here. And then I'm thinking we just get the cover back on, maybe pop the fuel line off. We'll feed the carb some fuel directly, and then we'll try to start it. And I do have a parts airbox. Seems to be exactly the same one that's on the machine. And we even have the missing knob. So we'll probably just use this cover and the metal piece, assuming this one has it. That part commonly goes missing, but yeah, this one does have it. Good. There's a fair amount of dust too on the filtered side of the airbox, so that is not a good sign. That means the filter at one point may not have been installed, and some dust, made it potentially down into the engine. So we're just going to add a bit of fuel, not too much, until we know everything's good. Also, I did find the model sticker on the back side of this rail. So this machine, it's actually a GP8000. And although there's no date of manufacture on the tag, it does meet the 2018 emissions standard. So that kind of dates it. This machine is not that old. Okay, and we are full of fuel. Levels holding steady. So needle and seat seem to be working. All right, let's give this machine a try. I've got a light plugged in and turned on. I've also got the kilowatt. Now, based on what I've seen, this should run, but someone got rid of this, and it's a fairly new machine, so I've got to imagine there is a problem. So the choke is on. Let's crank the engine. Okay, so there is a problem. Initially the engine started, everything seemed normal. The engine sounded healthy, the light turned on, but that was short-lived. Shortly after, the engine began to bog, which definitely could be misinterpreted as going under load. But I don't think that's the issue here. Based on the testing we did, we know the generator's good. I did try applying a bit of choke, and that made absolutely no difference. But I did hear a hissing sound. I think it was coming from the exhaust, and that is a common problem if the exhaust system is clogged up. Or in this case, I think the spark arrestor might be clogged up. So the engine isn't able to breathe, and like that, it's going to stall the engine like it just did. So let's remove this clamp. We'll get the screen off, and I can tell already that's definitely the issue. I feel tons of carbon packed in this pipe. So once this is removed and we start it again, it's going to blow a lot of carbon out of that exhaust. So the fact that it ran well for a few seconds, tells me that carbon was probably kind of loose in the exhaust, likely due to transport. And once I started the engine, it just blew around, built up in that pipe, and held back by the screen. Wow. So not carbon. I think that's rust. Yeah, definitely rust. So that's a first. Anyway, I'm going to leave the screen off for now, so that way next time we start it, anything residual will just blow out, and then we should be good. All right, let's try this again. We are refueled. This time, no spark arrestor screen. And I've also rolled this closer to the door. I've opened it up, so hopefully some of that rust blows outside instead of all over the garage. So let's choke it and try starting it. I kind of went into this assuming the worst, but it was just a clogged spark arrestor. So that was a pretty easy fix. And now that that's cleared, the engine is running pretty well. Now, the carburetor, not perfect. I did have to choke it just a tiny bit to get rid of the surge. So, potentially the carburetor's dirty, but I'm leaning more towards the fact that it's a replacement, and potentially the jetting on the pilot jet might be a little bit off. So I'm going to pull the pilot jet. We're going to open that up a tiny bit, and then we'll restart it, see if things improve. So I'm going to get this breather out of the way again, just so you can see kind of what I'm doing here. Now, there is adjustment right here for the pilot circuit, but that's only one of about 4 passages in the pilot circuit, and usually that will not stop a surge. So I did check it. It's actually 2 turns out right now, and you don't usually want to go past that. If you have to, then there's something off on the jetting. So we'll get the pilot jet out, leave the carb in place, and usually you have to go up 2 sizes to get the surge to stop. But in this case, we're very close. So I'm going to bring it up 1 size, and then we'll try it out. So what you want to do is find the last micro drill bit that fits, and then go 1 size up. So that one fits, but the one right next to it does not. So that one is a 77. So let's get that one out, and we'll make that jet a 77. Okay, we're through. Didn't take a whole lot. So it was probably almost a 77 anyway. So we might have to go up a bigger size, but let's drop this one back in and see if there's any improvement. Okay. So I'm going to refuel, restart, and hopefully this time we can run with the choke off. All right, let's give this another try. We are topped off with fuel. So choke on, contact. We're close, but not quite perfect. At times there was a surge, and other times that surge went away. So I did try applying just a bit of choke to see if that would improve things, and it actually started to add too much fuel. So I don't think drilling that jet another size is a good idea. Likely we're going to go too far. So I'm going to leave the carb alone for now. During load testing, we'll see, if it's up to the task. So now that we have some heat in the engine, I'm thinking let's get the oil changed. Although it looked clean, I'm not sure the quality of that oil or even if it's the right weight. So it's best to start fresh with some known good oil. All right, so before we get the cover back on, we do need to anchor these wires somewhere out of the way. Originally, I think they had these zip tied and kind of tucked in, which is not a good idea. Usually you anchor this right there. So I actually tried that and it worked, but the problem is they have such a big wad of tape here, you can't actually get the cover back on. The head of the bolt is really taking away the clearance needed. So I can't put a bolt there and get the cover on. So instead, might have to use the AVR as an anchor point. So yeah, something like that should work. So like that, it's pretty good. We should be able to get the cover on. Might add another zip tie right here. Just kind of leave it loose, just as insurance, to make sure that this absolutely cannot get pulled in. So I think it's safe to get the spark arrestor back on. It's not clogged up. It was just holding back that bit of rust, which led to all the problems on this machine. So let's get it secured. And there's an up-close look at the oil. So the good news is there is no metallic in it, no shiny bits. But the color of the oil, definitely a bit off. I was expecting it to look a lot newer. It almost looks like there's a trace amount of water contamination in there. So it's a good thing we got that changed out. As far as the rest of the machine goes, the battery is taking a charge, so I'm going to let that charge up overnight. We're all back together here. Exhaust and the spark arrestor good to go. Really, the only question mark here is the carburetor. There is a slight surge without a load, and hopefully that doesn't come back to haunt us when we do the load test. So I'm going to let the battery top off with charge, and in the morning we'll get this outside, try it out, and see if it can pull its rated load. Well, now that it's outside, I can see that this frame is really orange. I don't think this is the factory color, and the fact that the sticker's missing and we have a nice black finish tells me that for sure someone went through this at some point. Anyway, place your bets. This machine, it is rated at 8,000 watts, but it's only a 420cc engine. And usually the machines I see that engine on, the highest I see is about 7,500 watts. And even that is a bit of a stretch. Some of them can't do it. So 8,000, it is possible, but everything has to be tuned right. So, I would say we will see at least 7,000 watts out of this. But 8,000 watts, yeah, I guess we'll find out. So let's get the engine started. While it's warming up, we'll double check the output using the kilowatt to measure the frequency in the hertz. We'll use the amp probe to measure the total harmonic distortion and the oscilloscope to see what the sine wave looks like. We'll then put on a half load of 4,000 watts. And if everything looks good, we will go for the max of 8,000 watts. All right, no issues at all getting the machine started. So without a load, we're at about 5.2% THD, and the sine wave fairly typical. It is jagged and we'll clean up a bit under load. So let's bring on a load, starting with 2,000 watts. No issues, about 4,000. Yep, engine's holding fine at 60 hertz. THD, it did jump up to 17.7%. And the sine wave, not as jagged, but it is a little bit deformed now. So we'll give this a few minutes, and if no surprises, we'll go for the max of 8,000 watts. Alright, we got the screen off, and it actually blew it out when it built pressure. So, yeah, I'm not sure we're going to be using that again. Anyway, without a load, we now have a slight surge, which isn't that surprising. The engine, it can breathe easier now, and because of that, it also needs a little more fuel. So we might have to drill that pilot jet out a little bit. Alright, let's bring the load on again to 4,000 watts. And we'll give it a few minutes to make sure there's no problems. But the engine is running quite well under that kind of a load. right, no issues at all at 4,000 watts. So let's try 6,000. No issues, so we'll swap that for the 2,000. So now we're back up to 6. Definitely getting pretty loud. Let's try 7,000. Yep. 7,500. 8,000. It's actually performing quite well. So under that kind of a load, we're at 20.3% THD. And the sine wave, a little deformed, but fairly typical. So we'll give this a few minutes, make sure it can hold. Yeah, it's not happy about it, but it's doing it. So I am kind of surprised. So let's take the load off and we'll let things cool down. And then we'll shut it down. All right, guys, and that is pretty much it. So this one surprised me on a couple fronts. I went into it assuming the worst. Based on the description, it sounded like the stator might have a short, and it ended up being a very easy fix. There was just rust caught in the exhaust, and the spark arrestor was holding it back. So once we got that cleared out, I thought we were good to go until we put a 4,000 watt load on it. It ran fine for a short time, and then the hissing sound came back. The engine began to struggle, and it actually blew a hole in the spark arrestor, which helped the engine recover, but it still wasn't breathing right. So we pulled it off, put the load back on. It had no issues at 4,000 watts, and to my surprise, it pulled 8,000 watts with confidence. We were holding at about 59 Hertz, and although the engine was shaking and loud, it was performing like it should. So, I hope this video helps someone. Thanks for watching.